So this is what I'm wanting to rotate, this region in here. All right. Now, think about what this cross section would look like if I took this cross section here and I rotated that cross section about the x-axis.
Like a drill. What is that?
I don't know.
Are you saying that, or would it be symmetrical?
Again, y'all really don't know how bad my feelings were hurt when they didn't hire me for the art position that came open a couple of years ago.
Or this last year?
Or this last year, I know. Well, I didn't even apply this year. I was like, I'll show them. Let them come begging to me. So, still waiting for them to come begging to me. All right, so, but that one cross section would rotate right here, right? So tell me what this is going to look like as I rotate this segment around here, and then it's going to go back into Miss Conley's office, and then it's going to come back around. Like a donut?
That's an onion.
A very skinny donut, right?
Why is it a donut?
Well, because this is what's going to happen. You're going to have, and this is actually called the washer method, as opposed to the dryer method. That never gets old. All right, so anyway, we take one complete rotation, so this is what a cross section would look like. We're going to have a bunch of infinite washers in here. Now, how do I represent the metal area of the washer?
The whole area of the circle minus the area of the air.
The area of the... I've never heard it referred to as the air, but you are correct. So it's the area of the outer circle minus the area of the air. So that's what we're looking at. Now, let's talk about what that's going to look like. What is the... So I'm going to have pi from -2 to 2 of some circle squared dx minus, I'm about to get off the board here. If this video goes viral, I don't want it to be me off the screen here. All right, now, how do I represent this outer circle?
8 minus x squared minus x squared.
Not quite. The outer circle is just 8 minus x squared. Because if I take this, each one would go up to that 8 minus x squared portion. So it's just 8 minus x squared. Now, you were on the right track with your thinking, because now I get to the inner circle. In other words, what would give me the air, and what's that going to be? X squared. So I'm going to subtract from it, coordinated, x squared. So I've got pi times, and I'll just put the pi on the outside. I didn't have to. I didn't intend to originally. That. Okay, now, there's a second thing I'm going to do here. I'm going to combine this, and I'm going to make this one integral. And I can do that because both sections have the same limit of integration. So it's going to be pi times -2 to 2 of 8 minus x squared minus, and I'll just go ahead and write it as x to the 4th. Are y'all okay with that? But the important thing here is that you don't say that this is 8 minus x squared in here. Because you'd wind up squaring the wrong thing. You have to do it as the area of the outer circle minus the area of the inner circle. Does that make sense?
Yes.
All right. So, there's a second thing that's happening here. Or a third thing. That was the second thing. The third thing that's happening here is, guess what? Whatever happens on the left-hand side of the y-axis is equal to what's happening on the right-hand side of the axis. So how do I use that to my advantage?
Take out 2, and then
Take out a 2, so I would go from
0 to 2.
0 to 2. And how do I have to deal with that?
2.
By 2. Multiply by 2. So I have, again, that was the famous wrapper, 2 pi. Times, all right, that may have gotten old. All right, so now I get here, square this out, so this would be what? 64 maybe?
Oh, 64
Minus 16x squared? Remember, it's 2 times the first term times the second term. And then what's x squared squared? X to the 4th, so I have plus x to the 4th minus x to the 4th dx. Okay? So, 2 pi times 0 to 2 of 64 minus 16x squared dx. Are y'all okay with that? Now, I could go straight from integrating there, but I can make my numbers smaller by doing what?
By 6.
Yeah, factoring out a 16. So I get 32 pi times the integral from 0 to 2 of, what would that be now? Well, remember I didn't factor out 32, I factored out a 16. 4. So, yeah, 4 minus x squared dx. I don't know why all of a sudden I decided to put a parenthesis up there, but I did. So, let's anti-differentiate that. Four becomes? Minus x squared becomes? Minus x cubed over 3, good. We are going from 0 to 2. Everybody still okay? All right, so let's plug in 2 again. Do my writing from right to left. All right, so 4x is 8. X cubed over 3. 8 thirds. So that becomes 24 thirds minus 8 thirds, which would be 16 thirds. Times, well, that's a horrible bracket. 32 pi. And what is, am I off the screen? No, I'm not off the screen. Okay. What is 32 times 16? 512, yeah. So 512 pi over 3. That's kind of funny because we had the similar problem with that the other day from homework. It was 512 over 3. But this became 512 pi over 3. Yes?
Why is it again that we can take out a 2?
Because the volume here, from 0 to, 2 is identical to the volume from -2 to 0.
Okay.
So it's a lot easier to integrate using 0 than it is to integrate using -2. So that was what was happening there. Any other questions? All right.